What if I was asked to find a power series representation of the function natural log of 1 plus x cubed on this interval? Well, I'm still going to use the geometric series that I do know to be able to solve for this. But this might be a little bit more complicated. So, what do I know about the natural log? Well, I need to get it into a form I like better. So, the natural log of 1 plus x cubed, well, the derivative of is going to be 3x squared over 1 plus x cubed. And this is something that's much easier to work with. So in other words, the integral of both sides, the integral of this is going to be equal to the natural log of 1 plus x cubed. So let us use this to our advantage to be able to find the power series of f of x. So I start off with my natural log of 1 plus x cubed, which is equal to the antiderivative, or the integral, of 3x squared over 1 plus x cubed. All right? So this is something that's much easier to work with. Now we want to be able to deal with this integral, this function right here. This is, of course, dx. So how do we get this into a form that we can deal with? Well, let's pull out the 3x. So we have a 3x squared on top, and then a 1 over 1 plus x cubed dx. Now, if we do our u substitution of u equaling x cubed, negative x cubed, we'll have it in the form that we need. So we have, this is equal to the integral of 3x squared 1 over 1 minus u dx still. Then we're going to move down, and this is what we can convert to our power series. So we move down, and we get the integral still of 3x squared, and then we have a sum, n equals 0 to infinity, of u to the n, all this with a dx. Now we can substitute back our u, and we still have the integral of 3x squared, sum, n equals 0 to infinity, of x to the 3n dx. Now when we multiply in, we pull this in, and we're going to get the integral of 3x to the 3n plus 2, right, dx. Now we do our final step, which is integration. And how do we integrate this function? Well, we just do standard integration. Oh, whoops, I forgot the sum here. We're going to pull our sum out, n equals 0 to infinity, and pull our integral sign in. We're going to flip that way. And we're going to do our integration. So we get the sum from n equals 0 to infinity of, well, we raise it by 1, and we get x to the 3n plus 3. We get a 3 here, all divided by 3n plus 3. Which we could, if we want to simplify this down a little bit, we could say that this is n goes to 0 to infinity of x to the 3n plus 3, all divided by n plus 1. And, of course, n equals 0. When you do that, you have x to the third power, right? You have no constant. So the actual antiderivative would be equal to, a plus c value here, right? But since we want equality, at all x values, they should be the same. So at x equals 0, you have natural log of 1. So x equals 0, you get natural log of 1, which is equal to 0. So at x equals 0 here, we should also get 0. X equals 0, everything else would be 0 because you'd get a sum of zeros. So in order for this to be 0, c has to equal 0. And your final answer would just be this term right here. And there is no need for any plus c because c is in fact 0.